We're back. This is Mr. Sutton bringing you two lessons on volume. In this one, we'll be dealing with volume of prisms and cylinders. For our real-life application, we'll figure out how much water a barrel can hold. For your warm-up, see if you can identify the difference between surface area and volume for a solid. All right, let's see how you did. So surface area, just to review, that's the space that encloses a solid. So this is an outside measurement. It's two-dimensional, and because of that, we have squared units. Volume, on the other hand, is the space enclosed inside a solid. This is an inside measurement. It's three-dimensional, and because of that, we have cubed units. Let's begin now by talking about volume of prisms. To find the volume for any prism, think of this base area here as being kind of like an elevator that rises from the zero to the top floor. And it's rising a distance of h, enclosing all of the space inside. So then you're going to have the base area times h for the volume of this solid. Now we can get a little more specific with some of our shapes, and this is what the MCAS formula sheet has on it. For a rectangular prism, your length times your width is your base area, and you just have to multiply that times the height. For a cube, s times s squared is the base area, it's a square, times a height of s is going to give us s cubed. But as we have seen, not every prism is a rectangular prism or a cube. Try this triangular prism. Pause the video, see if you can find the volume for this thing. Alright, so for this we are going to need the general formula of base area times height. Now the height, remember, that's the distance between the bases. So that's going to be this 4 here. The base area, that's going to be the area of this triangular base. So we're going to have 1/2 base times height, or 1/2 8 times 6, which is 24. Again, the height is 4. So multiplying 4 and 24 together, we end up with 96. And now this is volume, so this is going to be meters cubed. Let's do another one, this time a real-life problem. A water barrel has the following dimensions: height of 4 feet, radius of 3 feet. To the nearest tenth, how many cubic feet of water can this hold? So volume of a cylinder is kind of like a prism. You have base area times the height. The base area now is a circle, which is pi r squared, so you really just have pi r squared times height. And this formula is on the MCAS formula sheet. So pause the video and plug in what you need to here. All right, so we've got pi times 3 squared times the height of 4. And plugging that all in the calculator, that's going to be 36 pi, or 113.1, and that's going to be cubic feet. This next problem is a little bit of a twist on the last one. Given the volume and the height in the diagram below, find the value of x, which is the radius here. So pause the video and see if you can puzzle this one out. We're going to start with the volume formula. Again, volume equals pi r squared times the height. And then we have to plug in what we have. So we already know the volume. It's 72 pi. We don't know the radius, but we're representing that with x. And then the height, they said, was 2. So plug in all that in. We just have to solve for x now. Now, we might be tempted to use the calculator here, but we could probably get away with not using it. We know that when we divide both sides by pi, these pi's are going to cancel, and 72 divided by 2 is 36. So really, you just have to take the square root then of 36, which is 6. And that's going to be centimeters because it's single dimension, and we don't need the plus or minus because this is a real measurement. We'll do one more volume problem. Here is your final boss battle for this lesson. Pause the video and see if you can find the volume of this weird shape. So one thing you may have decided while trying to find this volume is that there's not kind of a canned volume formula for an L, a three-dimensional L. You're going to have to kind of mix and match different pieces here. One method you could use is to split this up into two different rectangular prisms and then add the volumes together. So we know the volume formula for each of those is going to be length times width times height. So finding the volume of, we'll call this V1 for this top box here. That's going to be a length of 4, width of 4 also, and then a height of 3. So that's going to be 16 times 3, or 48. Volume 2 down here, we have a length of 9, same width, still 4, and then a height of 2. So that's going to be 36 times 2, or 72. Adding those two together, we're going to get 120. And that's going to be, well, they didn't give us units, so cubic units, but there's no real units to put here. Another method of doing this is to figure out the base area of one of these gigantic L's and then multiply that by the height. You could think of this as kind of an L-shaped prism. So what's the base area of this L? Well, we're still going to have to split things up to find that, but this time we're splitting things up in 2 dimensions. So we have the area of this top part here, which would be, let's see here, 4 times 3. And then we have the area of this bottom-shaped piece, which would be 9 times a height of 2. This would be 12 plus 18, which is 30. And then we just have to multiply that by the height of 4 right here, the distance between the L's. So that would be 4 times 30, also 120. This concludes our lesson on volumes of prisms and cylinders and other weird shapes. Next time we'll tackle volumes of cones, spheres, and pyramids. Until then, this is Mr. Sutton signing off.